All right. Well, I'd like to welcome everybody. Today my name's Mike Riley, and I'm here to talk about Intel and Unity together, how we're adding more flexibility to game development, and we'll talk about some of the things that we're doing now and into the future here. So there's lots of tablets in the marketplace today, and Intel's made great strides to get x86 chips into some of these devices. We've got over 46 million now and rising, so there's a lot more devices to target now, and it's really easy to build x86 into your game for Android when using Unity. Can I get a show of hands? Who's been familiar with x86 support since Unity 4.6? Anybody currently targeting x86 out there? And can I also get a show of hands, how many of you are Android developers out there? Great. So what I'm going to show you today is how easy it is to add this support into your app in Unity. And I'll go into a little bit of details of what's happening behind the scenes and some of the default settings and things. And so another thing we're going to talk about is some of the tools to help optimize your games, and so you can get the most performance and best battery life for your users. And Intel has some tools that they offer in addition to the Unity profiler, which is actually really good. And it's called GPA, which is the Graphics Performance Analyzer. It's a free tool available from Intel, and you can get it from software.intel.com/GPA. It gives you low-level access to counters for the CPU and GPU, and at the end of the day, it helps you make more judgments about draw calls and effects. It's got some additional tools on top of that with the system analyzer and also a frame analysis tool for OpenGL calls. So when you take a look at the system analyzer, it gives you active trace metrics for CPU, GPU, and OpenGL and DirectX. You get real-time feedback, and you can look at all your installed GPUs, your CPU levels to see if you're maxed out. When you look at the frame analyzer, you can look at all the draw calls for each target, and you can look at a lot of detail. You can go into the API log specifically, and you can identify that specific draw call. And you can look at textures, states, geometry, and a lot more. So these days, everything's mobile, and we're not just interested in performance anymore. Battery life is a big issue. I know, I'm always like, I wish I could get more battery out of my device. And these x86 optimization tools will help you take that Android app even further. And we have a good document out there that talks about this. I've got a link that I'll show you a bit later in the presentation on how to best optimize your app for x86. So at the end of the day, you can carry out experiments, you can capture frames and later analyze it offline. You can load capture frames from the system analyzer, and you can use these tools on any Unity development, PC or Android. So at the end of the day, it's nice that you don't have to step out of your tool chain on a different machine or anything like that. So something that's experimental that's going on, this is one of the nice things about the partnership of Unity. First we did the x86 native support, and now we're looking at an experiment where we're going to integrate this GPA functionality into the Unity environment. So in addition to the Unity profiler, you'll have this Intel specific for looking at hardware counters for the CPU and GPU. So now you can stay even more inside the tool chain. And they're making good progress on it. They've got a prototype that's working that they showed off in Berlin this year. But like I said, it's experimental, so I can't say when or if it's going to come out. And as I mentioned, the Unity editor already has a nice profiler. We're just adding more to that to help you go even further in your optimization and get the best power and performance out of your app. So as mentioned, I mentioned the article about optimizing your app for x86 on Android. And this is really worth taking a look at. It's about a 40-page document, but it's broken up into all these different segments, and you can really get hands-on with optimizing, doing script optimizations in your assets in the editor, batching, HDR stuff, and also splitting the binaries. So splitting the binaries, so what do we mean by that? All good? All right, sure. So splitting the binaries, what do we mean by that? So by default, since 4.6, when you target Android, a fat binary is specified. So it will support both native libraries for ARM and x86. Has anybody out there used the Android NDK? Any native Android developers in the audience today? So we got one. So basically, this is adding, the SO file for x86. When you build your Android app today with Unity, it's just putting the ARM library in there. This will add the native support. So in the past, before 4.6, a binary translation would occur on the x86 device. And so that's why now, when you add that shared library, you see a lot better performance and power metrics. So let's take a look at if you say you're size constrained in your Android app and you don't want the extra size. Let's take a look at how you can switch between the two. Working with customers, what I've seen so far is that it's adding about 6 to 12 megabytes of extra size to your app. So I'm just going to create a new project here. And when I look at the build settings, look at the player settings, and if I go down the other settings, when I look at the device filter here, you see the fat binary, the ARM, and x86, and you can simply target one or the other by selecting these. So normally it's all happening under the hood, but if you need to take a deeper dive into that, you have the flexibility to select which library you'd like to include. So the next topic we're going to discuss today is kind of what's coming, some stuff we already have out there today and what's coming next year. And can I see a show of hands? Anybody heard of Intel RealSense Technology? A few people. Anybody attend the Intel Developer Forum recently in San Francisco? Okay, well, we've been bringing this technology to market this year, and also, who's familiar with the Connect SDKs? Anybody use that out there? So what you'll see in this 3D camera is it's a similar type of technology. It's a 1080p color camera doing RGB and also a depth sensor, so you can get real-time view of both color and depth in an environment. And Intel, they've built an SDK around this technology, and we call it RealSense, and it supports a variety of languages, C++, C#, and Java. We have hand finger tracking built in, facial analysis, speech recognition, 3D segmentation, so you can take an object out of a scene, and also augmented reality. So it's got the 10-finger gesture recognition. And so for developers, what does this mean? I think it gives you an opportunity to differentiate your app. Intel, they're working hard to build this hardware small. So I mean, it was demoed in a mobile phone at the Intel Developer Forum this year. So you're going to see this technology in laptop form factors. This laptop I have up here today, it's a Lenovo Yoga 15, and it has a RealSense camera built in the front-facing camera. And you're going to see these on tablets and also handsets. So I think if you can add new capabilities to your app, hand tracking, face tracking, you could possibly differentiate your app and be able to be discovered more easily. If you're looking to get started with this technology, what do? Do you have to buy a machine with a RealSense camera on it? No, you don't have to. We have developer kits that are available today. They're $100, and I'll show some landing pages here in a little bit on how you can get all the tools and information that you need to take a look at the SDK. The SDK is free. So we're at a Unity conference, so what's this mean for Unity? Well, because this great partnership we have with Unity, they've done the heavy lifting once again, and we have a nice plugin for Unity. So shortly here, I'll show you how easy it is to integrate this technology onto a game object. There's lots of samples in the SDK. I'll show you the sample browser here shortly, and we'll take a look at what's possible. It's currently available for Windows. Android support's coming sometime next year. So today, it supports Windows 8, Windows 10, and you can download it today. Software.intel.com/RealSense is kind of your portal to all the good stuff that you can download. There's also a Getting Started blog series that shows you how to do some basic things from getting the package in there to adding basic hand face tracking into your app. So check out software.intel.com/RealSense. And let's take a look at a demo. Let's take a look at the download pages, the browser. We've got a sample that comes with the browser that will show some basic hand and face tracking, and then I'll show you on just a simple game object how you could add this to your app. So this is the main landing page for the RealSense technology, and we have front and rear-facing cameras. If you get one of the front-facing camera kits, it's got like a clip on it, so if you're using a laptop, you can clip it on the top there. And to download the SDK, simply just click this download link, and it'll ask you to submit your email address, and then it'll send you a download link. To get started, there's a driver that's necessary to download first. They call this the Depth Camera Manager, or DCM, if you see that throughout the documentation. So install that first, and then install the SDK. And this is the page where you can purchase the developer kits. This is the front-facing camera here. And then we've got a wealth of collateral for you to help you learn about different use cases and samples with this technology. So that may seem like a bit of a maze, but the key is software.intel.com/RealSense, and you can drive into these pages. I'll admit it's not the easiest to find all these, but just scroll down the page and you'll see it. That's why I point them out. So now let's take a look at the SDK browser. So I've installed the DCM, installed the SDK, and on your desktop there's a link to this SDK browser. So I open that up and it's got a wealth of samples here. So you can sort by language, and we've got some Unity specific ones in here. So let's take a look at that. And I can do this right on the viewer here. And so I said I've got RealSense camera installed on this laptop, so I can do this right on the machine. So you can see it tracking my fingers, my hand movements. Kind of a more interesting one here is let's look at some hand tracking and face tracking. So the idea here is I'm going to try and move these cubes with my hand here. Let me select hand. It's fairly sensitive. So I have a point of reference. So I'm, in my head, I know that I've done this cube, so now I go. So I'm trying to go around a circle. I'm doing an okay job. So now let's try my head. Let's see if I can do it with face tracking. My neck's a little stiff from the flight. As you see, I'm not like right up close to the laptop. I'm a little bit of a distance away, and it still works well. It's hard to get that upper, maybe if I... There we go. Anyway, I think you get the idea. Let me show you next how easy it is just to get some basic functionality on a game object. Any questions so far? Okay. So let me make a new project. So the first thing to do is to import the package, custom package, and inside the RealSense SDK folder is the Unity toolkit. The path to that is it gets buried underneath the program files Intel RealSense directory. And if you go try and do this on your own, I mentioned that just because it's not totally clear in the documentation. All right, so let's import this. All right. So we've got some actions that come with the kit, and I'm interested in the tracking action. So let's just make a cube here. And all I gotta do is drag this onto the cube. So now I've got my script here. I can select the kind of action that I want here. I can do a hand or face tracking, object tracking. So it's real easy to change that. Let me constrain the environment a little bit so the cube doesn't fly off of the screen when I move it. So I'll change this world box here, and let me also add a little smoothing factor so it's not as jittery when I move it. And we got hand tracking on first, so I can hit play. And for face tracking, let's try that. Yeah, come on. There it goes. I'm too tall. I did all the, I was sitting down at my desk. Anyway, that's how easy it is to, prototype something with this technology. So just to summarize, we're trying to give you another way to differentiate your apps by adding some unique capabilities and interaction, and with Intel trying to integrate this hardware on common form factors like laptops, tablets, and phones. It's going to have more devices out there for your users in the future. So at the end of the day, you can be more creative. Gives you a chance to stand out. And we're trying to give you the tools to make better games, more optimized games, give the users more battery life, to basically have to make less trade-offs if you're targeting another architecture. When I get to the point where you're not even thinking about the architecture, and I think we're getting closer to that. And this SDK, it's something they're really investing in, and you're going to see a lot more capability added to this over time. They've got a feature in beta right now where it can even detect a pulse on somebody. So it's got a lot of potential. And with that, that's all I had to share today. And could I answer any questions for you guys? Or the question is, can you only track the face, or can you track expressions? And currently only just the movement. Any other questions? Yes, sir.
What about hand gestures? Do you support those locks, or is it just thumbs? Do you actually detect that you're pointing this?
It can detect like open, closed hand, right, left hand. I don't know if it can. It does do the fingers, but I don't think it does pointing specifically. Any other questions? Yes, sir.
Yeah, earlier with the profiler, I know it's going to be integrated in Unity eventually, but at this point, like today, do you need to make a standalone application, or can it be done in editor? Like, does the profiler be run next to the editor?
The question is, if you're using the Intel optimizing tools, does it have to be run in the editor or standalone? And you can do both. It's recommended to do it standalone to get the best optimization result, but you can run it in the editor, just to stay inside the environment. All right, well, that's all I had today, folks. Thank you very much for coming. And we've got a booth out there in the exhibitor area. Come by and talk to us. And if you want to dive in deeper on this, I'll be over there and be happy to help you all. So, see ya.